If you had problems with the last PowerPoint, get ready for stoichiometry.
Here are some important terms to keep in mind when doing stoichiometry problems. Limiting reagent is the reactant that limits the amount of product produced. It is important to keep in mind that the reactant with a lower mass is not always the limiting reagent.
Next is the excess reagent. The excess reagent is the reactant that will remain after the reaction is complete.
Percent yield is the ratio of actual yield to theoretical yield expressed as a percent. Percent yield can be found by dividing actual by theoretical yield and multiplying by 100. This is the mole map. In stoichiometry, it is your best friend. You can use the mole map to convert grams, moles, or molecules into one another, as well as convert moles of one substance to moles of another, as long as you have the balanced chemical equation.
Next, you look at the mole map and find which box you are starting with and which you are trying to get to. The path you find will tell you which conversions to use.
Using the given information from the previous step, set up a unit multiplier. Make sure all units cancel before proceeding to any calculations. Now let's put the mole map into action, shall we? The fizz produced when an Alka-Seltzer tablet is dissolved in water is due to the reaction between sodium bicarbonate, NaHCO3, and citric acid, H3C6H5O7, as shown by this balanced chemical equation. You may want to pause the video for a moment to copy down the equation. Please pause now.
In this reaction, 1 gram of sodium bicarbonate, the limiting reagent, reacts with 1 gram of citric acid.
We are now going to use stoichiometry to figure out how much carbon dioxide will be produced in this reaction. Looking at the mole map, we can see that we are going from mass of A, which will be sodium bicarbonate, to mass of B, carbon dioxide. We use sodium bicarbonate as mass of A instead of citric acid because it is the limiting reagent. We can now set up our unit multiplier.
Okay, so first we're going to start with 1 gram of sodium bicarbonate over 1, of course, because it's the first part of our unit multiplier. Then we're going to multiply by 1 mole of sodium bicarbonate over its molar mass, which is 84.009 grams. Make sure you write the whole label. Now we're going to use the balanced chemical equation we created and create another factor of 3 moles of CO2 over 3 moles of NaHCO3. And finally, we need to use the molar mass of carbon dioxide, 44.011 grams of CO2 over 1 mole of CO2. Now, when you come out with this, the answer is 0.524 grams of CO2.
Please make sure your answer is correct. Remember, no naked numbers! Okay. Next, we want to find out how much of the excess reagent, citric acid, will remain after the sodium bicarbonate has reacted completely. If you see here, I'm going to put this up for you. You take 0.524 grams of CO2 all over 1. Multiply it by 1 mole of CO2 over 44.011 grams of CO2. Smaller mass. Then its mole to mole ratio all over the other ratio. Then multiply it again by 196.124 grams molar mass of citric acid. Which you already have because it's going to be on the table. Anyway, it's on the side. We end up with 0.762 grams of H3C6H5O7. Please make sure your answer is correct.
In the first problem, we found that 0.524 grams of carbon dioxide should be produced. However, this number is only the theoretical yield. If the reaction had an 84% yield, how much carbon dioxide would actually be produced?
Alright. To find this, we must multiply the theoretical yield, 0.524 grams, times 0.84, since there's an 84% yield, and we will get 0.44 grams CO2 and an 84% yield. However, this number is only the theoretical yield.
That's our presentation. We hope you enjoyed learning about stoichiometry.